Hello and welcome to lesson 5F. I can identify the properties of rhombus and prove the quadrilateral to be a rhombus. A rhombus is in fact a parallelogram or a quadrilateral with four congruent sides, which makes a rhombus a special type of parallelogram. And parallelogram, there we go. A rhombus is equilateral, that's an I, because all four sides of a rhombus are congruent. So we could mark that down here on our figure to show that all four sides are congruent. If a figure is a rhombus, then the diagonals will also be perpendicular, and the diagonals are going to bisect a pair of opposite angles. So let's mark all this up on our figure here. So if I draw on my diagonals, there's FH and EG. What's going to happen is those are going to be perpendicular and they're going to bisect the opposite angles. Notice the consecutive angles aren't congruent, but the diagonals bisect very nicely. We also know it's a parallelogram, so we know that opposite sides are parallel. And yeah, so that's basically all the cool stuff you can pull out of a rhombus. Now, we're able to actually prove something to be a rhombus with three different methods. We can either prove that all four sides of my quadrilateral are congruent, which is really our definition of a rhombus. Or we can prove that a quadrilateral is a parallelogram and its diagonals are perpendicular. Notice I can't use this one, though, without first proving it's a parallelogram. Or we can prove that the quadrilateral is a parallelogram and one diagonal bisects a pair of opposite angles. So let's take a look at some figures here. I want to determine if these are rhombi. This first one, I've got a quadrilateral with four congruent angles, so that's a yes. He is a rhombus because he's got four congruent sides. Now my next figure has a pair of parallel sides and a pair of congruent sides. They are not the same side. So this, we can't even prove this to be a parallelogram, let alone a rhombus. So he's a no. Now in this next one, I've got congruent diagonals, but congruent diagonals, we could say it's a parallelogram because my diagonals are bisecting each other, but we can't really say that it's a rhombus. Okay, and we'll come back later to some cool things about diagonals in a couple of future lessons. Now my next one, we've got opposite sides are parallel. Well, that's our classic definition of a parallelogram. But we don't have enough to show that it's anything more than that. So it's not necessarily, let me fix that, friends. It's not necessarily a rhombus. And in my last one, I've got that my diagonals are perpendicular. Well, perpendicular diagonals will prove that something's a or will prove that something's a rhombus if it's a parallelogram. Well, in my given back here, they told me that I'm dealing with parallelograms, right? They told me we're dealing with parallelograms, so I can say that this is a rhombus. If they didn't tell me that, I couldn't say that it's a rhombus. And this last one, I've got a diagonal that's bisecting my angle, so it is a rhombus. Okay. So let's take a look now and do a formal proof. Now remember, in order to prove something's a rhombus, we first have to prove it's a parallelogram. And guys, I'm going to use the abbreviation parallel-ogram. Parallelogram, I hope we get that. And then we have to prove it's a rhombus. Okay, so it's going to always be kind of a two-section proof. Let's look at what they give us. They give us FG is congruent to EH, FG is parallel to EH, and they give me that FG is congruent to FE. So I'm going to be able to prove that this thing is a parallelogram because I have one pair of congruent, parallel, opposite sides. Okay, that's how I'm going to be able to prove it's a parallelogram by that theorem that we learned in the lesson on proving parallelograms. Then once I do that, I've got 3 of my sides are congruent. I also know that opposite sides and parallelograms are congruent, so I'll be able to prove all 4 sides congruent. So that's how I'm going to prove it's a rhombus. I'm going to prove it by showing that all 4 sides are congruent. That's my plan. Okay, here is the plan. Now let's actually do it. Okay, so we have our statement and reason. Well, they start off by telling me FG is congruent to EH and FG is parallel to EH. I'm just going to write those 2 right now because they're the 2 statements I need to prove that my shape is a parallelogram. So we're going to go ahead and write this, and we're then able to see that, or write that EFGH is a parallelogram because we have one pair of opposite parallel congruent sides. Okay, that's my reason. All right, now let's list our other given. We also know that FG is congruent to FE. That's given. Well, we've got FG congruent to 2 of the sides, but not the 3rd side. So let's look at that. I know that FE must be congruent to GH, right? Because the opposite sides of a parallelogram are congruent. Okay. And so by transitive property, FG must be congruent to GH as well. Woo! Hello, friends. I did not mean to do that. Let's try this again, shall we? FG must be congruent to GH by transitive. POC. Well, I'm now going to take a little bit of a cheat. We've got all sides relating to FG, so I'm going to do this lovely long line where I say that FG was congruent to GH, which is congruent to FE, which is congruent to, what's my last side? EH. And I'm going to say that's by transitive times many, many times. It's a little bit of a cheat, but I think it's okay, guys, rather than doing each individual side is congruent to each other individual side. So now we've shown that all 4 sides are congruent, so that means that EFGH is a rhombus because all 4 sides. Would it stop doing that? Sorry, friends. All 4 sides are congruent. By the way, guys, this is our technical definition of a rhombus. So I could have actually said definition of rhombus here instead of writing the description, but this is the only one where that's the case. So, all right, guys, thank you so much for watching this video. Go ahead and take a look at the MML.